be talking about the brightness of stars and why stars are so bright and how distant that they are from Earth kind of affects the way that we see them and how bright they are, okay? Because we know some stars look really, really dim, some stars look really, really bright, some look really big, and some look really small. So we're talking about just what are stars today. So I want you to just look at this picture for like 30 seconds. Just quietly look and see all the different things that you can notice. Olivia, can you sit your chair down so you can see behind you, Ben? Thank you, thank you. So just look at all the different things that you notice, the different colors, the different sizes, everything. And then we're going to talk about it. Oh, sorry. There you go. Alright, Dylan, what's one thing you noticed?
It's green, it's orange, it's like a blue, it's like blue, purple, white, like, I forgot, it's like a flower.
You talking about all the different colors down here?
Yeah, it's like, and that's so, something like that.
What do you think these colors are? A lot of people are saying like the northern lights. Does that kind of look like that? I kind of think it looks like that too. What's another thing, Lauren?
Some of the stars are a little bit brighter than the others, and in bigger clumps.
So like this here is kind of like a really big cluster of stars, so it looks a lot brighter, right? What do you all see like the really, really big star that I see?
Yeah.
Why do you think it's so, it's this one, right?
Yeah.
Why do we think it's so much bigger than like maybe all these little ones down here, Zoe?
Maybe because it's way hotter than the other stars.
Not hotter, but there's another, Olivia?
Like it's closer to Earth.
Right. Right, it's so much closer to us, that way it looks so much bigger. That's why our sun looks giant, right, compared to all these stars, because our sun is the closest star that we have to us. What else do you notice?
It's a gradient of colors.
A gradient of colors. What about the bottom along the horizon right here, Jaya?
I think it might be a solar eclipse because you can see the sun. It's like down at the bottom and it's almost setting, and half of it is like light and half of it is like starry and like night. And like if you can look behind that mountain, you can see like a little bit of the sun, and I think that's how the colors are forming.
Okay, that's a good observation. What else, Audrey?
The stars that like the corners are kind of look like.
Yeah, do you notice, do you see any constellations maybe within this? I know someone in the other classes said that they did. I see maybe like a small one right here. Do you see that? How it's kind of like forming some different shapes and patterns. But more specifically, what's about the sun? What about the sun? Braden? Well, there's two little bits of light, but this is our sun, right? So is the sun a star based on what else we see around here?
Yeah.
The sun is a star, right? So what do you think a star is? Pace, what's a star?
A giant cluster of gas, dust, and material formed together with so much friction and colliding that it creates so much heat that it becomes a star or a supernova.
Yeah.
Sometimes a black hole.
Yeah, very good. So it's a big ball of burning gases and dust, and it's holding it all together, and it's producing two different things. Do you know what it's producing? Zoe?
Gas and light.
Not gas, light, and what else, Gabby? Heat, right? That's why we're able to stay so warm, and that's why plants can grow, and that's why we have water, because it's giving us enough heat that we can live. It's also giving us sunlight, right? That's why it rotates. Yeah. No, I changed it on purpose. It's okay. And we already talked about we do think the sun is a star, right? Okay. So what's some things that we wrote down in our know? What do we already know, Addie?
The sun. No, the further the star is, the dimmer it is.
What else? Zoe?
Colors change because of temperature.
Okay. Yeah. What else, Andy?
Stars are different sizes.
Different sizes. Audrey?
If the stars are farther away, they'll be different.
So the farther they are, the dimmer they look. Good. What else, Madison? Say it one more time. Yep, Sirius is brightest, but it doesn't look brightest because it's so far, right? So it looks like normal. What are some questions that we wrote down that we need to know, Mia?
Why do we have stars?
Why do we have stars? What else? Banner? It's okay. We'll come back to you. Parker?
When is the sun gonna explode?
When is the sun gonna explode? That's
Probably
what.
never would have known.
What else, Merly?
Can you touch?
Can you touch stars, Audrey?
How long does it take for a star to explode?
Right, so we have a whole bunch of questions. We might have more questions than we even wrote down, and that's okay, because that's what we're going to learn about, right? So flip to the next page. We're not going to fill out our learn, because we didn't really learn much yet, right? So we have an article, and it's called Why Do Some Stars Shine Brighter Than Others? And that's hopefully going to help us answer some of our questions. Probably not all of them, but some of them. So we're going to do this. We're going to read it as a class, but we're going to popcorn read. If you haven't done that before, I'm going to explain how it works. Yeah.
I was gonna say for question, if a star turns into a black hole, could it consume other stars?
That's a good question. I think it could, but we can do some more investigating in that in the next couple of days, right?
How?
Well, that's what we're going to learn about, right? We are going to answer all your questions in this unit, okay? I
And
promise.
also, if a star explodes, would another star explode too?
I don't know yet, but we'll have to do some research to figure that out, right? Like a chain reaction, yeah. It's okay if you want to ask questions. That's how we learn, right? By asking questions. Let's just make sure we raise our hand when we talk, okay? All right. So this is how we popcorn read. So let's say Levi starts reading. He's going to read just the very first paragraph. So he's going to start here. Have you ever looked up into the night sky? He's going to read. Once he gets to the end, he's going to say, pop to Katie. And she's going to read the next paragraph, okay? And then she's going to say, pop, Tegan, okay? And then Tegan's going to read the next paragraph. So you have to be following along because you never know when someone's going to call on you to read. Don't raise your hand because we're not going to just pick you. It's got to be real quick. So as soon as you finish, you're going to pop to someone else. You must be sitting yes.
Yeah.
Okay? Who wants to start? You want to start? Adi, go ahead. Be a good listener.
Have you ever looked up into the night sky and marveled at the thousands of stars you can see? Some you can barely see, some twinkle, and yet others shine very brightly. If you could examine each star closely, you would find that they come in all different sizes and colors. However, here on Earth, most of them look about the same. So, why do some stars shine brighter than others?
You have to say pop and then pick whoever.
To me.
What are stars? Stars are born from enormous clouds of dust and gas called nebulae. These nebulae are mostly made up of helium and hydrogen. Gravity pulls some of the gases together and floats. As the clump grows bigger, the soon-to-be star collapses. This makes the center of the clump so hot it starts to turn hydrogen into helium. This process, called nuclear fusion, releases a lot of light and heat. Pop to Audrey.
Are all over our universe. Sometimes the nebula is left behind after a star explodes in a supernova. Other times gases and dust simply gathers in the same area in space, creating a nebula. Over time, stars can form from these nebulae. Pop to Kate.
There are many different types of stars. In the Milky Way galaxy, there are about 200 billion stars. One way scientists classify stars are by temperature. Scientists also know.
So what you're doing, we made the model yesterday, right? You finish it. Okay, we're trying to finish. You're going to use... You're going to use the data that you researched in your groups to answer the questions about the constellation that we made yesterday. Does that make sense? So number 1 will say which of the stars would appear the brightest and why, which would be the dimmest, why, and then you're gonna pick 2 of the stars at each of the E1, compare and contrast them in terms of brightness, and then which of the stars from your research are most similar. So that means the 2 that are closest together, right, are gonna be most similar. And then number 5, which constellation do we pick, and then just write something interesting about it. Okay? So you can talk in your groups. Yes, Brandon.
So the light years, the lower the frequency.
Yes. Yeah. So the first thing you're going to do is you're going to find your distance from the wall. So you're going to have 4 different distances. You can start up close and you can get back, or you can scoot back farther, or you can start farther back and scoot up. It's up to you. They can be whatever distances you want to be, okay? If you look on the ground, are we listening to instructions? Because some people are talking. Thank you. If you look on the ground, each of these blocks is 12 inches long, or 1 foot long. So if you're back 1 block from the wall, you're back 1 foot from the wall, right? So it should be pretty easy to kind of measure how far away you are, okay?
Can I just say 5 blocks away?
No, you need to do it in feet or inches. So that's what you're going to do here. That's the first thing you're going to put here. And then you're going to measure it in centimeters, which your centimeters looks a little different. Yours is on this side. Okay? So you're going to measure it with your ruler in centimeters. Okay? You're over here. Yours is over here. And centimeters will be right here. That's what you measure it in. And then you're going to convert it to your millimeters, which is in the middle. Okay, do we remember how to convert, or do we need a little refresher? Need a little refresher? Okay, it's real easy. So you have our step ladder here, right? Our King Henry doesn't usually drink chocolate milk. Do you remember that rap that we did with our metric system? He died drinking chocolate milk. So we start here, right, at chocolate, and we're going to milk. So how many steps are we taking? 1 step. Chocolate to milk? We're taking 1 step. So if we start with 4, hold on, dinner, 1 second, and our decimal point is here, we're taking 1 step, right? Which means we're moving our decimal point 1 spot. To the right, because that's the way we're stepping, right? So to the right. So 4 centimeters is 40 millimeters. So really you're just adding 0, you're moving the decimal point 1 spot over for all of those.
So we're using decimal.
Yep, does that make sense? Yes, Dinner. Unit, or like your base unit, so that'd be like liters, meters, grams. Yeah. Alright. So this is how you're going to do the experiment. The lights are going to be off so you can see your flashlight. So you probably need to sort of spread out, but you need to find a good spot to where you can be straight. So don't be like curving around tables or anything like that. You want to be straight against the wall or against the locker. You can go. Not yet. Sorry. Not yet. Let me explain the directions and then you can find your spot. So wall, locker, cabinet, doesn't matter as long as you're straight. Okay? Let me see your ruler real quick. Listen, you're going to shine the flashlight. So do you see this bright circle in the middle? That's what you're measuring. You're not measuring all the way around it, just this part. So you're going to hold your ruler up. Probably 2 people should hold 1 of each side. Then you're going to measure it. And you're going to either scoot back, like step back farther, or you can get closer and have a really small one. Okay? Then once you're finished with all that, your group is going to write your conclusion based on what you found and if your hypothesis was correct or not. Okay? You can use the wall, the locker, but you can't use the floor or the table. You have to be standing up. Okay? Yes.